Hello all, good morning. This is Dr. S. Subalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Probability Statistics and Numerical Methods, and we are on to the topic Runge-Kutta method. So this video is a design thinking approach on Runge-Kutta method, and myself Dr. S. Subalakshmi. Here comes the introduction part. The Runge-Kutta method is a powerful and widely used numerical technique for solving ordinary differential equations as discussed earlier. It provides an approximate solution to initial value problems. What do you mean by an initial value problem? The initial value problems are the problems which have been discussed earlier or given earlier with the initial condition, where an analytical solution is difficult or impossible to obtain. This method is especially popular in science and engineering because of its accuracy, simplicity and efficiency. So, this Runge-Kutta method is really accurate, simple and efficient enough. The first step in design thinking is the problem definition. Before that, we will define the problem of ordinary differential equation with initial value conditions. Here we consider an ordinary differential equation which is of the form dy by dx is equal to f of x comma y, which has been discussed earlier. That is the general form of an ordinary differential equation. Y of x naught is equal to y naught. Here our objective is to compute approximate values of y at the discrete points, which is x1, x2 and x3 as given earlier. H is known as the step size, which we have discussed earlier in the previous videos. This is what the algorithm is. What is our algorithm? We have to find the constants k1, k2, k3 and k4, and then we will be finding the incremental value of y, which is del y, and we will find the value of y naught plus 1, which is y1, using this particular formula. Now coming to our design thinking concept. What is our design thinking concept here? Automated systems using design thinking, which is the first design thinking concept on automated systems. We are empathizing it. Modern vehicles require real-time decision making systems for autonomous driving, safety and performance optimization. Engineers and drivers need accurate real-time models of car motion and response. So which means we are going to find the autonomous driving techniques, safety techniques and performance optimization for the this will be serving as the problem statement. So this here comes the defining part, which will be the problem statement. How can we accurately predict and control the complex vehicle dynamics, example braking, steering, suspension in real-time environments? This will be our problem statement as per the empathy part in the design thinking concept. So what is that thing we are going to find? We are going to find the braking system, steering and the suspension system in real-time environments. The next step is to ideate the ordinary differential equation, which means we are using ODEs to model the vehicle like skid, acceleration or wheel rotation. We have equations regarding to ordinary differential equations regarding the skid control, acceleration or wheel rotation. So we apply Runge-Kutta method to numerically solve these equations during real-time simulations and integrate with sensor data. The sensor data comes with speed, GPS and gyro for better predictions. This is our ideation part. This ideation will serve as a baseline for the Runge-Kutta method to perform. Next step is to prototype. What is our prototyping? Implementing RK4 Runge-Kutta method, which is the fourth order Runge-Kutta method in embedded systems. Embedded systems are the AC controlled systems, electrical circuit control systems, which have been applied in the real-time scenario of car braking system and bike braking system. The first thing will be the anti-lock braking systems, and the second thing will be the electronic stability control systems and adaptive cruise control. So in these things we are going to apply the Runge-Kutta method to solve or to find it or to simulate with the existing ones to find the better performance things. So we can simulate it with the help of MATLAB and Simulink. MATLAB is one such simulation platform wherein we can get n number of data. So how do we test? The testing vehicle models on hardware in the loop, HIL simulators, which means hardware in the loop simulators, wherein it will be in the manufacturing processes, and monitoring performance in real driving conditions using data loggers, which means data loggers are nothing but the lineup things in cars and performance like trucks, which will be monitored using GPS trackers or scientific equipments. to evaluate response time, accuracy and safety compliance, which means we are going to evaluate all these things using our Rangi-Kutta method 4, and we will test it for, so that we will be getting an very implemented or very valid performance using the speed, accuracy and the things which we have discussed as the empathy part. So this is how we use design thinking in automotive concepts using Rangi-Kutta method. The second thing will be in industrial automation using design thinking, which means industrial automation. Automation is nothing but automatically doing something, but here we will be discussing the industrial automation techniques. The first thing is to empathize. What is the empathizing part? Empathy part here. Factory engineers need reliable, responsive control systems to handle machinery with minimal downtime and high accuracy, which means the time management and the accuracy thing are to be empathized here. So how we will be discussing it with the defining part. How can we model and control dynamic industrial systems like robots, monitors, robot motors and actuators in real time with high precision? The high precision is our main aim. This high precision is our main aim here. So this precision and the accuracy within the time given is stipulated time is our defining part. The third thing is to ideate using the Rangi-Kutta method, fourth or Rangi-Kutta method to solve motion control ODAs that represent system behavior. So system behavior can be represented using ordinary differential equations as we have discussed earlier in the previous slide. With that in hand, we can solve that particular Rangi-Kutta ordinary differential equation using Rangi-Kutta method. And to develop real-time control logic using feedback from sensors. Applying RK-based models for optimizing PIDs. So develop real-time control logic using feedback from sensors, which is temperature sensor, position sensor and pressure sensor, and RK models for optimizing PID controllers. This is the ideation part for automotive industrial automation. And what is our prototype? Prototype is nothing but the demo model, which means implementing RK4 algorithms and programmable logic controllers, which is considered to be in the manufacturing processes, are to be in the to be performed inside the managed platform or inside the lab using microcontrollers and logic controllers. Simulate actuator behavior using RK integration with control loops. Control loops can also be helpful here using digital tensor systems for validation. These are the prototyping models that can be done. And testing. We are going to run real-time control tests on assembly line robots or CNC machines. Measure error margins, latency and energy efficiency. Calibrate system response with light feedback using RK systems. As discussed in the previous automation model also, here also we are going to test using the real-time drivers or real-time robots or real-time cars for the testing process and examination process. And in conclusion, design thinking provides a structured centric approach to problem solving, as we have discussed earlier, with all types of methods. Rangi-Kutta method enables accurate real-time solutions to complex differential equations, making it ideal for engineering systems for required precision and responsiveness. So these are the types which is this can be empathized, defined, ideated, prototyped and testing can be done using this RK4 method. And finally, on the conclusion, what we can say is this synergistic approach bridges creativity and computation, producing solutions that are not only technically sound but also relevant, scalable and user-focused. From automotive systems to industrial automation, this integration ensures efficiency, reliability and innovation in system design and control. This is what we expect here. Efficiency, reliability, accuracy and innovation using our design thinking concept. So this is how we implement design thinking in Rangi-Kutta method. Thank you.